Understanding the mechanisms behind malware's ability to configure itself for Autostart is crucial in the realm of cybersecurity. This cunning capability ensures that malicious software persistently executes, compromising systems and data each time a device is turned on. Through exploring the depths of Autostart configurations, we empower ourselves to dismantle these digital traps, safeguarding our digital domains against the relentless tides of cyber threats. Building on the foundation of understanding Autostart mechanisms in malware, I will narrow my focus to a practical demonstration, dissecting a piece of malware to reveal a simple yet effective Autostart technique on Windows. By deconstructing this code, we not only demystify the process, but also equip ourselves with the knowledge to detect, disrupt, and defend against such stealthy maneuvers. In this video, I unveil a fragment of assembly malware code, extracted via IDA64 free. This code leverages Windows API to run itself on user login process, embedding itself within the Autostart sequence. This demonstration not only showcases the technical prowess behind malware design, but also highlights the critical importance of understanding and countering such maneuvers in the ongoing battle for cybersecurity. On Windows systems, one common method to achieve this is by making registry modifications that instruct the system to automatically execute the malware upon user login. The Windows Registry has several locations, such as Run and Run Once keys, where programs can be added to execute automatically, like HKEY_current_user software Microsoft Windows current version run. Malware might use Windows API calls such as regopenKeyX, regsetValueEX, and regcloseKey to interact with these registry keys. The process generally involves opening the registry key, using regopenKeyX to get a handle to the specific registry key where the Autostart configuration will be added. Setting the value, using regsetValueEX to create a new value within the opened key, specifying the path to the malware executable as the value data. This action configures the system to run the malware at user login. Closing the key, using regcloseKey to close the handle to the registry key after the modification is made. While understanding these techniques is important for cybersecurity professionals to develop effective defenses, sharing or using knowledge of malware tactics for any purpose other than defense and education is strongly discouraged. For those looking to protect systems, focusing on security best practices, regular system scanning, and user education is key to mitigating the threat posed by such Autostart mechanisms. During a cleanup of an infected Windows PC, I stumbled upon a 64-bit Windows executable malware. This malware configured itself to restart after user login using a very classic technique, which I look forward to showing. The code fragment implementing the Autostart was decompiled with IDA64 free, and fortunately the code has no obfuscation techniques and is easy to understand. This assembly fragment illustrates a sequence of operations performed by a malware Windows program to achieve persistence by setting itself to Autostart via the Windows Registry. Here's a step-by-step commentary on what the code is doing. Initial setup. The first two lines are storing RBX and RDI registers values into space allocated on the stack. These could be arguments or important values that need to be preserved. Push RBP and LeRBP, RSP1E0H, prepare the stack frame for local variables and possibly for saving the current function's base pointer. Stack allocation. Sub RSP 2E0H decreases the stack pointer, allocating space for local variables and function call usage. Security cookie. The next few instructions deal with a security cookie used to protect against stack buffer overflow attacks. The cookie is loaded, XO-read with RSP, and stored near the bottom of the current stack frame. For this malware, it was not so important. This code is generated by compiler. 0 initialization. XOR eddy and moving eddy to RSP plus 2E0H plus HKEY initialize a local variable to 0 to use as a flag. Getting module file name. Calls get module file name A with ECX cleared indicating the current module to retrieve the executable's path, storing it in a buffer on the stack. The value 104H is the value of max_path constants. Preparing for regopenKey.exe call by setting up arguments to open a specific registry key. Software Microsoft Windows current version run for modification. If the key is successfully opened, the code proceeds to determine the length of the file name, the executable path, dynamically by incrementing through it until it finds a null terminator. The value 0FFFFFFF8000001H is the value of constant key _current_user. regsetValue.exe is then called to create or set a value, health PC check, in the registry key with the path to the executable as its data. Health PC check is a misleading name. All these settings ensure that the program starts when the user logs in. Finally, regCloseKey is called to close the registry key handle, cleaning up. I hope you found this video enlightening and engaging. If you're curious to explore more, I've got you covered. Just click the link in the description below to visit my website. Don't forget to hit the like button if you enjoyed this video, and subscribe to my channel for more amazing content. Thank you for watching, and I can't wait to see you on my website. Until next time, stay curious and keep exploring.